Alright guys, here we go. This is our final lesson for week 6 here. Again, we are still working with this normal curve, and if you notice, this is the same exact example that we had from the previous lesson. But in this case, now we're looking for something called a z-score. First thing, let's talk about what a z-score is. Let me come over here and just put a little z-score, and we'll make a quick definition. What the z-score tells you is how many standard deviations away a piece of data is. Now we're only going to do a couple examples here because I'm going to kind of talk about it a little more than anything. But the way to find a z-score is we actually have a formula. To find a z-score, we take whatever piece of data it is, we're just going to call it x, subtract it from the mean, and then divided by the standard deviation, because you take the piece of data, find how far away from the mean it is, divide it by standard deviations, and that tells you how many standard deviations away you are. So we can use the z-score to see how kind of far away from the average you are, which means you can have a positive or a negative z-score. It doesn't matter if it's positive, you're to the right of your mean. If you have a negative z-score, you're to the left of your mean. More than likely, it's probably better to be having a positive z-score. Say you're taking a test and the average test is like a 70. If you have a positive z-score, then you scored above a 70. If you have a negative z-score, you scored below a 70, if that makes sense. So we're going to see how to find z-scores here. Now the first thing I want to do is remind you guys how to fill in our normal curve. Again, we have this information, 800 employees, the mean is 100, the standard deviation is 15. This is the same example here. Let's go ahead and fill in those percentages. 34, 13.5, 2.35, 0.15, and you can go the other way. Again, this is the same example that we did in our last lesson. I'm not going to spend a ton of time filling this in. Again, how we fill in our table. The mean goes directly in the middle, so that's 100. As you jump to the right, you're adding standard deviations. So we're going to go 100 plus 15 is 115, plus 15 more is 130, plus 15 more is 145. If we jump to the left now, we're subtracting. 100 minus 15 is 85, minus 15 more is 70, minus 15 more is 55. That's how we filled in our table. Again, in the last lesson, we had more in depth on how to do that. So, how this is going to work. All I want to be able to do is find a z-score or kind of go the other way. So, again, the z-score tells you how many standard deviations away from the mean a piece of data is. For example, if we were talking about 115, let me say, we'll go example 1. Let's say someone got a score of what is the z-score if someone got 115. Again, z-score is how many standard deviations away a piece of data is. Now, if you remember, each jump we go here is one standard deviation, right? That's a jump of one standard deviation. So, this is the most basic example here. Notice how 115 is exactly one standard deviation away. So we could just go over here and say, oh, the z-score is 1 because it's just one standard deviation away. If you want, you can plug in the data. Again, to set this up, we just need to know what's the mean, what's the standard deviation, and what piece of data we're looking at. Now we already know that the mean is 100, the standard deviation is 15, which means we can find the z-score. If we want to do this, we're just going to plug in 115 for x. So we go 115 minus the mean is 100 divided by the standard deviation of 15, and I promise you we're going to get a 1. 115 minus 100 is 15. 15 divided by 15 is 1. So the z-score is 1. 1 standard deviation to the right. Now just keep in mind, since 115 is to the right, it should be positive, where if we looked at something to the left of the mean, it should be negative. We're going to do another example here, one that's not as nice. Let's say example 2. Oops, it's kind of light. Example 2. What is the z-score if someone scored, let's say, 73? So notice, if we look at our numbers here, right, 73 is going to be over here, somewhere in between 70 and 85. First thing to note, it's to the left of 100, our mean, so it should be negative. I'm going to put should be negative. Second thing, it's not going to be a perfect number because it's not exactly 70, it's not exactly 85. So again, what we're going to do is we're just going to use our formula. In this case, our x is 73, and our mean standard deviation stay exactly there. So we set up our z-score formula. Z equals x minus, so 73 minus mu, our mean is 100, divided by the standard deviation, which is 15, and we can find that z-score. So we're going to go through. Again, if you need to use a calculator, take out your calculator now. We go 73 minus 100. That's a negative 27, divided by 15. And you get negative 1.8 as your z-score, which is good because it is negative. It's on the left-hand side. And notice it's more than 1, because if it's more than negative 1, that means we went farther than one jump, which we did. We went a little bit farther, about 0.8 farther, so that makes sense. 1.8 would be your z-score. The last thing that you can do on an example like this is, instead of you finding a z-score, the question can give you a z-score, and you can find that piece of data. You can find the x value. So let's do one on the positive side. It doesn't matter. The process will always be exactly the same. Let's say if a z-score, let me rephrase it. If you had a z-score of, let's say, let's go 2.3. What score did you get? So in this case, they just gave us some different information. Instead of them giving us the x like they did here, we need to find the x. So we still have that same formula, that z equals x minus mu over sigma. It's just in this case, they gave us z, and we know mu and sigma. So we're going to set up that equation, and I'll show you how to solve it. So in this case, again, they gave us z, so we're going to go 2.3 equals, we don't know what x is, that's what we're going to find, minus mu, which is still 100, divided by our standard deviation of 15. And now we can solve this for x. The way you're going to solve this for x is previous ways. We need to get rid of this 15 on the bottom, so we multiply both sides by 15 first. That cancels out those 15. 15 times 2.3 is 34.5. Equals x minus 100. And then the last thing, to get x by itself, add 100 to both sides, and you end up getting x equals 134.5. So if you got a score of 134.5, an IQ score of 134.5, then you were 2.3 standard deviations away. Let's see if that makes sense. 134.5 would be somewhere over here, right? That would be about 134.5. Again, the z-score was 2.3, so let's see. That's 1, 2, and a little more, which makes sense, right? 2.3 is a little more than 2, so the z-score matches up exactly with the score we got there. That's the last thing that we're going to go over there. Again, z-score is just another thing we can look at with these normal distributions. The z-score, again, is telling you how many standard deviations away from the mean or from the middle a piece of data is. If you have any questions, feel free to reach out. That finishes up week 6 for us. Have a good day.